Hello, everyone. Welcome back to another video. This video is actually a requested one, requested from a dear subscriber. Um, and he wanted me to make a video about parametric equations and polar coordinates. So this video is about parametric equations. Stay tuned for my next video, which will probably be out a day or two after this one's uploaded. So just keep your eye out for that next video on polar coordinates if you need it. Yeah, so let's get started. So I'm going to be using notes that I took when I took the course, pre-calculus honors. I couldn't even begin to tell you where these notes are from, which book. So just know that it's not mine. Just gonna quick disclaimer. It's not. They're not mine. They're not my like problems that we're about to solve. I don't know what book they're from, but they're not mine. All right. So we absolutely need to know for parametric equations these two little formulas. These are a given on every single problem. This is for the x, and this is for the y. There's an x component and a y component to every single parametric problem that you're going to study. The x component is simply the initial velocity times cosine theta. The theta is whatever angle that they give you. So if they say a cannonball was shot at an angle of 45 degrees to the right, your theta is going to be 45 degrees, cosine of 45 degrees, radical 2 over 2, times t. T is your time. That is I believe they call it the parameter of these parametric equations. You want to find out where these things are going to be at a certain time. Time is your parameter. You have x in terms of time and y in terms of time. That looks like this, right? And you'd say equals blah, 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 equals blah, blah, blah. Simple. So yeah, and that's the x. The y is just a little bit more stuff to it, but it's the same idea. Y equals initial height plus initial velocity times sine theta. Again, theta is the same. T, which is your parameter, minus 16t squared, your parameter again. So let's move on to just a quick little warm up to get us into the mindset. So, blah blah blah. So consider the path of an object. Here, consider the path of an object that is propelled into the air at an angle of 45 degrees. When the initial velocity of the object is 48 feet per second, it can be shown that the object follows the parabolic path. This is a rectangular equation that they give us. If we're trying to find the parametric equations, it's simple. We just use the equations that we had, that we know, that are given in every problem. X equals initial velocity times cosine theta t, times cosine theta t, y equals h plus sine theta t minus 16t squared. Let me just make sure I got that right. Yep, looks good. Okay. All right. So we just plug it into these equations. So we have, I'm going to change my color. We have x equals initial velocity. It gives us the initial velocity. If you're in or have taken physics, you would be able to solve these equations in my opinion, in an easier fashion, but this isn't physics, this is pre-calculus. So equals initial velocity, which is 48, times cosine 45 times t, and that equals 48 times radical 2 over 2 t, which equals 24 radical 2 t. So that's x. Now let's do y. So now we have y equals consider the path of an object that is propelled into the air at an angle of 45. So I don't believe that there's an h in this problem. To see the usefulness, consider the path of an object that is propelled into the air at an angle of 45. It can be shown that they're a parallel path. Okay. Yeah, it doesn't, there is no h in this problem because it says it's propelled into the air, meaning it wasn't there in the first place. So we'll have 0 plus initial velocity, which is 48, times sine theta, which we know is radical 2 over 2, because that is sine theta and cosine theta are the same when theta equals 45. That's just unit circle. T minus 16t squared. Solving this, we have y equals 24 radical 2t minus 16t squared. All right, so we have our parabolic equations here. So now, let's say you wanted to graph the trajectory of the whatever it said it was a object. Let's say you wanted to graph the trajectory of the object. So then we would make a table in which we say at 0 seconds, 1 second, 2 seconds, 3 seconds, then we just plug that in. So if we plug in 0 here, we have x is 0. If we plug in 0 for t here, we have y equals 0. We're just plugging, so if we plug in 0 there, and there, x equals 0, and y equals 0. So at t equals 0, everything is 0. At t equals 1, we have x equals 24 radical 2, and we have y equals 24 radical 2 minus 16. At 2, we have 48 radical 2, and at y, we have 48 radical 2 minus, gosh, the math is 16 times 4, 64, easy enough, minus 64. And for 3, we'll have 72 radical 2 and 72 radical 2 minus 16 times 9, which is 144. Okay, now, I mean, these aren't very lovely numbers, so I'll give you that, but it's not a big deal. I'm going to go through and I'm going to turn all these numbers into decimal. Okay, so I turned all the numbers into decimal points, so into decimals, so it's easier to digest, because I personally, I don't know why, I can really judge numbers based upon radical 2 and stuff like that. So I just like turning it into decimals. You do you, though. So we see that at 3 seconds, the y is negative. And now this doesn't make any sense, because now that we're in physical problems, we can't have negative space. Once it hits the floor, it's in the floor. Because our object that we're shooting up into the air, it's going to be a parabola. That's why it's called a parabolic motion. And once it comes back down, that y is 0, and that's the floor. You can't go into the floor. So instead of doing t equals 3, we're going to find out where y is 0. So we'll have 0 equals 24 radical 2t minus 16t squared. We just simply made y 0. That's all we did. And by doing this, we can solve for t and find out where in what values of t make y 0. So we could take out a t, and then we'll have negative 16t plus 24 radical 2 equals 0. So t equals 0 as one of them, and then negative 16t plus 24 radical 2. We have negative 16t equals 24 radical 2. So 24 radical 2 divided by 16 is 2.12. Or we can just say, we could also just say 3 radical 2 over 2. Because I don't think decimal points are the most accurate. Although I like it better. Okay, so we see that y equals 0 at t equals 0, and y equals 0 at t equals 3 radical 2 over 2. Now, which one is actually useful to us? It's going to be not this one, this one. This one's useful to us because we already know that y equals 0 and t equals 0. We already said that here. We want to know what other point is t equals 0 because remember, it starts at the floor, it goes up and then around, up and over, parabola motion, and then it hits the floor again. So we want the second time when t doesn't equal 0. So it's going to be here. So at t equals, so I'm going to get rid of this one. And we're going to instead say, I'm going to move this over. We're going to instead say at t equals 3 radical 2 over 2. This is 24 radical 2 times 3 radical 2 divided by 2. Okay, that's 72 for the x. And then we have 72 again minus 16 times 3 radical 2 divided by 2 squared. That is a really low number. Oh, well, yeah, y equals 0. We got that. I got negative 3 times 10 to the negative 12th power, which is a number almost as close to 0 as you can get. And then it hit me. Yeah, we already said it's 0. Okay, so that's our thing. So let's graph this. Actually, I'm gonna make a new set of axes. It's gonna be like this. Just makes more sense. This is just the first quadrant. So we have 0. We have going from 33.9. I can see from these numbers, each one is going up by around 34. And this one, so if I go by 33 point, I can just go up by 34 basically every time. So 34, 68, and then I think that's 102. Okay. And then y is going from 0 to 3.9 to 17.9. Not very helpful, but we can go by 4, I'd say. So if I go 4, 8, 12, 16, 20. Okay. So far, so good. We can do that because x equals 0, y equals 0. Then we go 33.9 to 17.9. So I'd say 17.9 right about here, and 34.9 is basically at the 34 mark right there. And then we can also go 67.9, 3.9, 3.9 is right here. So boom. Maybe I'll make that even closer to 68 because these numbers are practically 68. So it was in the air for quite a short amount of time. And then 101.8, forget 101.8, and then 72 and 0. 72 is here, I'd say. Doesn't really matter. So this is the motion. You could have chosen, I don't know why I chose such big t values. So just so you guys can see a nicer version, this is what my notes had. It's from whatever book we used. Not this, that is just notes. Not this. But yes, this is what they had. So they did better t values than I did. They found the midpoint here. Yeah, so that's just what it should look like. Ours isn't wrong. It's just not very neat. Let's move on to the next one. Okay, so this is a problem I had on a study guide back when I took the course. And again, I don't know where this is from. I was just given it. It's not mine. I did not make this question up. It's from somewhere. If you know where it is, you can leave it in the comments and I'll definitely give it credit. But I just don't know where it is, but I think that these are good questions. All right, so consider a projectile launched at a height h feet above the ground at an angle theta with the horizontal. The initial velocity is v 0 feet per second, and the path of the projectile is modeled by the parametric equations used for feet per second. Okay, so use this for feet per second and use that for meters per second. Okay. All good there. So this is what we already know. It's everything that we just did, except for meters per second, you use this, and for feet per second, you use this. Simple so far. So a golf ball is struck across a flat fairway at an angle of 45 degrees with an initial speed of 45 meters per second. Write a set of parametric equations for the motion of the golf ball. Okay, so we see meters per second, we use this one. So we have, so for A, we have x equals, initial velocity is 45, cosine of 45 degrees is radical 2 over 2. So 45 radical 2 over 2, t. Y equals h within, okay, so I don't think that there is an initial height. It doesn't say anything about initial height. If they don't say anything about initial height 0. So 0 plus initial velocity, which is 45, radical 2 over 2, t minus 4.9, t squared. All right, B, determine how long the golf ball was in the air. So if we think through this, we know how long the golf ball is in the air by finding when the golf ball hits the ground again. Because if it leaves the ground at t equals 0 and it comes back to the ground at t equals some number, it was in the air for whatever that number was, right? So if we set y equal to 0, just like we did last time, we have 0 equals 45 radical 2 over 2, t minus 4.9 t squared, which means t equals 0 and t equals 45 radical 2 over 4.9. No, 45 radical 2 over 2 over 4.9. I'll just put divided by 2. All right. I had to erase all the work when I got the question from my notes. So I can't erase anything else. I get back all that work. All right, so that's what we have. So let's put that into our calculator. So again, it's 45 radical 2 divided by 2 divided by 4.9. That is 6.49. So t equals 6.49. So it's in the air for 6.49 seconds. That is our answer for B. All right, C, determine how far the golf ball traveled in the air. So if we just got the time when it hit the ground, then we understand how far the ball traveled by plugging in that value of t, right? If it was in the air for 6.49 seconds, then the x value at 6.49 seconds is how far it traveled, simply put. So we have C, and we would plug it into the x parametric equation, right? Because we're trying to find how far it traveled horizontally on the x-axis, sorry. And y would be up and down, x is left and right. I think you guys get it. So 45 radical 2 over 2, 6.49. So plug that into my calculator, equals x. So 45 radical 2 divided by 2, 6.49 is 206.51. Remember, it's meters because they gave us the problem in meters per second. So make sure not to put feet or anything else. Don't put anything else besides meters. You will get the question wrong. D. Determine when the golf ball reached its maximum height. Okay, so we know when it left the time it left the floor, 0 seconds, and we know the time when it hit the floor again, 6.49 seconds. So the time it reaches its maximum height, it's a parabola, would be, we know parabolas, the vertex, in other words, the vertex could either be the maximum or the minimum. In this case, it's obviously the maximum because it goes up and comes back down. So that's a maximum. We find the maximum because it's the midpoint of the two ends on a parabola. So if 0 is one end and 6.49 is another end, it's the midpoint between those. So we have 0 plus 6.49 divided by 2. So what is 6.49 divided by 2? 3.245. I'm just going to put 3.25 seconds. That is when the golf ball reached its maximum height. I'm not sure if I explained that well, but just let me go over it one more time. You find the vertex, right? The vertex is either the maximum or the minimum of a parabola. You find the vertex by finding the midpoint between two sides of a parabola. So if you have 0 and 6.49, we know those are both on the same x-coordinate, so they're both on the same part of the parabola. If the parabola is like this, they're both at one point, just one's on this side, one's at this side. And you find those by finding the midpoint, which is here. This is where the vertex is, 3.25 seconds. Okay. Let's go on to, that was D. Let's go on to E. Determine the maximum height reached by the golf ball. Okay, so we know what time it reached its maximum height. Now we just plug in T. So we would put that in the Y because we want to know how high it went. The Y is 45 radical 2 divided by 2. Okay, just plug that into your calculator. I doubt you're going to have to do this without a calculator. So that is 103.4 minus 0.9 times 3.25 squared, which is 51.76 103.4 minus 51.76. That's 51.64. That is the maximum. That was a really stupid box, in my opinion. Okay, that is the maximum height reached by the golf ball. And I think that's going to be the end of this video, just because I don't want to get too long. I want it to be a watchable video that someone can just quickly watch to study for a test. So if you have any questions, once again, please just leave a comment underneath the video, and I will look at every single one. And yeah, I'm just here to help. So if you also have a request for a video that I should make with specific problems or anything, or even if you have just a problem that you want me to help you with in the comment section, just let me know, and I'm only here to help. So thank you and have an amazing day.